Hello, welcome to the Power BI learning series. This is a continuation video from part 5.3 on the concept called Model the Data. In part 5.3 video, we discussed the first three modules on the topic Model the Data. In this video, we will discuss the rest of the modules. Once you learn the concepts in videos 5.1 to 5.4, you have completed around 50 to 60% of learning path for PL 300 examination. Even if you are not preparing for the examination, you have still learned the most important foundation concepts on these broad topics. The first three topics in this list were covered in the video 5.3. And in this video, we are going to check the 6 topics as you can see in your screen. To start with, we'll talk about writing DAX formulas for Power BI desktop models. When I say DAX, it means data analysis expressions, using which you can add 3 types of calculations to your data model. The first of them is known as a calculated table. The second one is a calculated column. The third one is a measure. DAX can also be used to define row-level security, which is shortly known as RLS, which are expressions that enforce filters over model tables. However, rules are not considered to be model calculation. If we speak about model calculations, they are normally 3: calculated tables, calculated columns, and measures. When you write a DAX formula, it may consist of expressions that use DAX functions, DAX operators, reference to model objects such as tables and columns, constants, and variables. Formatting your DAX formula is important, as that could help you to easily understand the formula, as well as debugging will be easier. In this demonstration, I'll be talking about some part of the theory, then jump into some part of demonstration so that you'll be having an idea about what I speak. Let me go to the demonstration mode now to show you creating a couple of calculated tables. For the sake of simplicity, I'm going to use a very simple Excel table which consists of 2500 rows of data. The name of the table is called Asia, and that is already loaded into one of my Power BI files. When we go to the table view component, I'll be able to see we have 2500 rows loaded into the model. As of now, we have only one table in the model that is called Asia, in which I have a column called profit. I now want to duplicate this table, and in the resultant table, I would like to add a column called tax, which should be multiplying the profit column by 12%. For that purpose, I'm going to create a calculated table for obvious reasons. Though there are other better methods available, I'm just going to use this opportunity to show you about creating calculated tables. I need to click the modeling tab, then click on the new table. Then I can write the name of the new table. Let us say I would like to call this as Asia 1. Then I'm going to use a DAX function called add columns for the Asia table, which means that please bring every column from the Asia table and then add a few columns or only one column that I am going to define now. What should I define now? I should first give a name for my column, which I would like to call as tax. Then I have to give an expression by which the tax should be calculated. For me, we have a profit column, which should be multiplied by 0.12, so that I will be getting 12% of the profit as the tax value. Let me hit enter. Then I could see a table called Asia 1 is created. And there is a small change in the icon here compared to the Asia table. I can see a calculator icon here, which means that this is a calculated table. If I could open the table view, I'll be able to see the new column called tax appearing next to profit column, which was created using this simple function called profit multiplied by 0.12, which means 12%. I'm now going to create one more table. This time I would like to call this as Asia 2, for which I am using another function called select columns. This function will go to the Asia table, and then it will create a column in the new name that you can see within double quotes given by me, for which it will pick up information from an existing column called order ID, and then it will create another new column called duration, for which it will be getting a value from a ship date and order date through the expression I have provided. So what I wanted to calculate is how many days elapsed for a given order ID to ship the product from the order date. I'm going to hit enter, and that should give me the new table. And when I go into the table view, the duration is in terms of dates and time, which I can convert into a whole number just to get the actual days. Then I can see for this order number, what is the time taken for delivery, and for some other order number, what is the time taken for delivery, and so on. So I have created now two different calculated tables. The first one brings every column from the existing table and adds any other column that I wanted to add. The second one brings only selected columns and then adds any other column if I want to add. Let me quickly show you yet another calculated table. Let me click on modeling. Let me click on new table. And this time I'm going to use a name called countries, for which I'm going to use a function called values from the Asia tables country column. Hit enter, and then the third calculated table is now loaded into the model. And when I click on the table view, I could see there is only one column called country, and that holds only 27 rows, not 2500 rows, because this function called values will get me only the unique values. No duplicates are seen here. We have created three calculated tables from one particular table called Asia. Let me create a card visual and then call for the country names from the Asia table. This column called country, being a text column, normally tries to give its first country name as if the data in the column is alphabetically sorted. I can change the way in which the data is being shown in the card from the first country name to count of the number of rows. And as we have already discussed, we have 2500 rows. Let me copy this card visual, and then for the second card visual, I would like to get the count from the Asia 1 table and then once again change it to count value. We'll be doing the same for the other two tables. As you can see, except the last table called countries, which has used the values function to get the unique values, rest of the three tables are showing the same value of 2500. I am back to my Excel sheet. Would like to add one row of information from an existing row and then change the name of the country in the newly added row to something called new country. Let me save this file, go back to my Power BI file, hit refresh. Now I could see that the changes that were effected for the original table called Asia are incorporated to all the calculated tables because these three tables were inherited from the Asia table. Any change that happens to the source for the Asia table is also reflected into the calculated tables. So please keep this information in your mind. We can create a couple of more calculated tables known as date tables or what if parameter tables. I'll be talking about them a little later. Prior to that, I wanted to inform you that adding calculated tables like that will inflate the size of your model. So I'm going to delete all these tables now. I'm now going to create a simple calculated column. As you can see, we have the Asia table and no other tables are available in the model now. I can go to the table view and then click on new column. I would like to call my new column as tax. So I have started typing tax equals, and then I start with a square bracket to populate the column headers. I want to calculate a profit that should be multiplied by 12% or 0.12. Hit enter. Then you will be able to see the calculated column is now available in the model. And when you look at the data pane, it is denoted by a slightly different icon. Certain points you need to know about creating calculated columns. Number one, you can write a DAX formula to add a calculated column to any table in your model. And number two, the formula is evaluated for each table row and it returns a single value. Number 3, when added to an import storage mode table like what you are seeing right now, the formula is evaluated when the data model is refreshed and it increases the storage size of your model. The fourth point, when added to a direct query storage mode table, the formula is evaluated by the underlying source database when the table is queried. In the data pane, as I told you already, calculated columns are enhanced with a special icon. That is a simple introduction about creating a calculated column. Maybe I'll be showing you a couple of more ways in which we can create and use calculated columns in the coming videos. Let me now move to the third type of calculations that can be done with DAX in your model called measures. And this is going to be an important discussion. You can write a DAX formula to add a measure to any table in your model. A measure will return a single value as a result, like a calculated column. However, a measure is different from a calculated column. Measures are evaluated at query time, calculated columns at the refresh time, and measures are on demand. The results are not physically stored in the model. Occasionally, measures are referred to as explicit measures. You may now ask me a question. Raja, if you are mentioning explicit measure, do we have something called implicit measure? Yes, we do have. Let me now move to an action mode to show you some information about what exactly is an implicit measure and what is going to be an explicit measure. I'm going to create a card visual and then would like to pull the profit column from the Asia table to show its value inside the card visual. The moment I hit the checkbox, you'll be able to see the card visual showing the value as 966.05 millions, which is the sum of profit. Profit column being a numerical column automatically aggregates. By default, it is giving me the sum, and this is what is known as an implicit measure. I'm not doing anything. I'm just informing that the card visual should be filled with the profit column's value, and I get the sum of profit automatically. That is called an implicit measure. Similarly, if I'm going to create a column chart and then would like to populate the value for the profit column, I still be able to see the activity of an implicit measure saying that the sum of profit is somewhere around 966 millions. The same results can be achieved by creating an explicit measure purposefully so that it can be used on different scenarios, because implicit measures have their own limitations about which we will have a discussion shortly. Let me now show you on creating an explicit measure that is absolutely equivalent to this value. I click on the new measure icon which says write a DAX expression that calculates a value from your data. Yes, that is what I wanted to have. I am now writing a formula which is named as Asia profit, which uses a function called sum, and then it adds all the numbers from the Asia table's profit column. So this is a measure, an explicit measure, which you can see is now available in the Asia table with a specific icon by which you will be able to understand that this value is not part of this table, but it is something called a measure. When I open the table view, I will not be able to see anything called Asia profit in the table because a measure is on demand and it will not be available physically in your model. However, you can call the measure inside any visual. For example, I have created a card visual and I am going to get the value from Asia profit, which is a measure. Now you will be able to see that this value is exactly equal to the implicit measure. So what is the advantage of creating a measure like this? This can be used under different scenarios, whereas implicit measures will have their own limitations. So this is a very simple introduction about a measure. With this, I'll be able to speak about two more calculated tables. Let me create a new table now in the name called CY, which stands for calendar year, using a DAX function called calendar auto. The moment I hit enter, a table called CY is created, and in the table view, you can see that it holds only one column called date, and the data type is date and time, which I'm going to change to date. I can also change the format according to my requirement. And the most important thing about a date table or calendar table is that this should be declared officially as a date table from the table tools using an option called mark as date table. And we have only one column, and that is the required column called date. And when I am going to choose that, I could see a message called validated successfully. Click OK, and it is now done. You will be able to see the change in the icon for the date column. For this date table, I can create any number of new columns which are all going to be calculated columns. For example, I would like to create a column called year, which can be created from the year function of the date column. Now you can see the year part of the date is picked up in this particular column. You may now ask me a question, Raja, what exactly you are trying to convey to me? All the previous examples were done with Asia table. We created Asia 1, Asia 2, countries, etc., which were all getting data from the Asia table itself, and then we created some sort of transformated or duplicated tables. Whereas now I am talking about creating a date table, which is a dimension table, and the purpose of that is I will be able to connect the date column of my dimension date table to the Asia table's order date column, which you can see will create a one-to-many connection, which is active. I can also connect the same date column to the ship date column in the Asia table, which will again create one-to-many connection. However, this will be inactive as only one connection can be active at a given point of time. If you are asking me a question why this is important, now you can see that this particular date column is going to play role-playing dimension, because I will be able to create a report based upon order date or ship date through the date column from my dimension date table called CY. So this is an important topic about which I have already created a full-length video for which you will get information shortly. Let me go back to the report view, and then I'm showing you Asia profit, which is a measure, is currently sitting in a table called Asia. It is always a good idea to have a separate parking table for all your measures so that your measures can be kept inside that table to avoid confusion between which of them are columns from tables and which of them are calculated columns and which of them are measures. For that purpose, I am going to show you how you can create a measure table. I have opened my Power Query editor, in which you will be able to see an option called Enter Data. I can click on the Enter Data icon, and when the Create Table option pops up, I can give a name here according to my needs. I prefer to call this as My Measures, and the column name I can leave as it is at this point of time. Click OK, and now I am able to see that a plain table called My Measures is created. Would like to click Close and Apply. Now the empty table called My Measures is loaded into your model, as you can see from the data pane. So I prefer to click on the Asia profit measure that was created by me recently. As I informed, current home table is Asia. I'm going to change it to My Measures so that this measure will now be moved to the newly created table. And then I would like to get rid of this empty column. I'm going to delete that from the model. Once it is done, you will be able to see there is a change in the icon for the My Measures table, and it automatically moves to the top in the hierarchy, so that it is going to be easy for me to locate all my measures that I am going to create. I have created a simple table visual that is showing the year values from the CY table and Asia profit using the measure. Now you will be able to see the purpose of creating an explicit measure like Asia profit. As otherwise, I may have to open my Asia table and check for which column contains the profit and so on. So we are now getting rid of all those issues. We can simply call an explicit measure in any of our visuals in the report. I'm now interested in identifying what is the year over year profit change. It may be an upward trend or it may be a negative growth. I'm interested in finding out such a value, for which I'm going to consciously click on My Measures table and then click on a new measure, so that I'll be writing a measure to find out the year over year variance of profit. What you see in the table is the profit per year. For example, 2010 we have a profit value, 2011 we have a profit value, and so on. Whereas I'm now interested to find out what is the profit for a previous year in case if I am talking about the current year is 2017, the previous year is 2016. For that purpose, I am going to create a measure which is called by me as profit year over year percentage. I am going to declare a variable called profit previous year equals, and then I hit the shift and enter key so that I can move to the next line. While you are trying to create a measure, it is a good idea to split them into different lines, format them in such a way that you will be able to find out which line is doing what task. Let me hit the tab key so that now I can use a function called calculate and then hit the shift and enter once again to select Asia profit, which was already calculated by me. However, now I'm going to recalculate that with reference to a DAX function called same period last year through the CY date column. So this is the purpose for creating a date dimension table. I can click on shift and enter once again, provide a closing parenthesis, shift and enter, and then I'm going to make a statement called return, which should happen after I declare a variable, which means the Asia profit will now be calculated with reference to previous year. If the current year is 2017, the variable will calculate the profit for 2016 and keep that in its memory, and the name of the variable is profit previous year. Now I'm going to use a function called divide, open bracket. I can hit the shift enter key, and then from the current year's profit, I would like to reduce the value for the previous year profit. You will be able to see the name of the variable I have created, profit previous year, comma, that need to be divided by, once again, profit previous year. I can close the parenthesis, hit enter, and I'm not getting any error message. I can safely assume that this formula is the correct formula. Hit on the cancel symbol so that it is now taken out from the screen, and then inside the table I'm going to call the value called the profit year over year. Before that, you need to ensure that the value is converted into percentages. I'm going to click on that. It takes a moment and it is done now. I'm going to click on the profit year over year percentage so that the value appears here. You may now ask me a question. Look, Mr. Raja, there is a 8.2%. What does it mean? Why should I see it there? That is your question. I'll give you an answer within a minute. I have opened the measure once again. I'm going to make a small change. After the return statement, I'm going to insert an if condition, and then I'm going to use a function in DAX called is in scope, for which I'm going to call the calendar year's year column. So if there is an year value available, then get me a division of the difference between current year and the previous year's profit value. Otherwise, do nothing. Since I have opened an if condition, I may have to close with another parenthesis, hit enter, and when I cancel this, now you will be able to see the total value column is not showing anything, because the profit year over year will be shown only when there is in scope for year value. If there is no year value, then it will not be shown over there. So this is a very simple introduction about using variables. We'll be talking about creating DAX formulas, DAX functions, variables in depth in the coming sections. But this particular module is to give you a simple introduction on creating calculated tables, calculated columns, and measures. I just need to touch upon yet another calculated table, which is known as a what if parameter table. In the modeling tab, you will be able to see an option called new parameter, and when you click on numeric range, you will be getting options. You can see that I had given a name called goal, and the data type is going to be decimal numbers starting with 1, incremented by 0.1, which means 1.1, 1.2, and so on, ends up at a value called 2 with a default value called 1. Please notice that there is a checkbox called add slicer to this page is available here. Let me click create and let us see what is going to happen. Please remember the name is called goal, and the moment I hit create, couple of things are happening. Number one, I'm able to see a slicer called goal, and if I could change the format of the slicer to show the values in terms of drop down values, or maybe I can change it to vertical list to easily understand how it gets created. You will be now able to see your starting point and your incremental values. You can also see that a calculated table in the name called goal has been created. And when you hit on the table view, you will be able to see one particular column called goal, which is actually generated using the generate series DAX function, as well as a measure called goal value, which is using a DAX function called selected value. The purpose of this goal value measure is if somebody is going to hit 1.2, it will say that the user has clicked the checkbox called 1.2. So that is the idea. You may now ask me a question, Raja, why this is important for me to learn, how this is connected to this example. Let us say that I am talking about a future goal for my profit value. I want to see the future profit. Had it been 1.1%, that means a 10% growth, what will be the profit value? Had it been a 30% growth, which means 1.3, what will be the profit value, and so on. For that purpose, I'm going to create one more simple measure, then make a demonstration. The new measure that I'm going to create will be called as a profit goal, which will be multiplying two values. Number one, the Asia profit, which is already available here, that will be multiplied by the goal value that the user is going to select from the goal column. Plain and simple. So if I'm going to copy this card and then call for the value called profit goal inside the card visual, then I'll be able to see a value called 1.16 billion. What does it mean? If this is my current profit, if I'm anticipating a 20% increase from that, I'll be able to generate a profit of 1.16 billion. Had it been 1.1, that means a 10% growth, I'll be getting a profit of this much. Had it been 1.4, I'll be getting a profit of 1.35 billion, and so on. So this is known as a what if parameter, which is nothing but a calculated table of a different kind. And with this introduction, I have completed what needs to be covered on this particular module. I'll quickly touch upon the summary slides so that you will get a summation of what are the points we have discussed so far. Then we will move on to the next topic. This is where we have started. You need to clearly understand that calculated table data is always imported into your model. So it increases the model size and can prolong data refresh time. A calculated table cannot be connected to external data. You need to use Power Query to accomplish that particular task. We discussed about values function, which may be useful in different scenarios, and you may read this by pausing the video if you are interested. Regarding the calculated tables, I just show you a quick method of creating a date table, explained about a role-playing dimension. I have also created a what-if analysis table. However, to get more idea on creating calendar tables and using role-playing dimensions, you may please watch my video part 2 as well as D for DAX 4.2. So this is the steps involved in creating a calculated table using the what if parameter. You just saw the demonstration. We discussed about calculated columns and how they can be created. We discussed about measures and how they can be created. Some conceptual information about writing DAX formulas that you need to know, and some information about DAX functions. Hundreds of DAX functions are available, each for a specific purpose. If you are an Excel user, you have a good news. Over 80 functions in Excel will work in DAX too. Since DAX originated from Power Pivot add-in for Excel 2010, this just happens. We just saw a discussion about the divide function. The divide function automatically handles division by zero cases when you provide an alternative result within that. The performance gain of using the divide function over using an if function to check if the denominator value is a zero is significant. You can use the divide operator in simple cases. However, when you are not sure what is going to happen in the denominator, could that be a zero? In such cases, please use the divide function. There is another function called distinct count. We'll be touching upon that in a future video. DAX operators, once again, I'll be touching upon them in a different scenario. I would like to highlight one important thing. The blank value is handled differently by different operators. Blank is treated as zero when acted on by arithmetic operators and as an empty string when concatenated to a string. We had a discussion about DAX variables. What is more important is you can see the profit previous year value has been called for twice after the return statement. And if this value was not stored in the memory, then it should have been calculated twice. So it is pretty much evident that a variable declaration can improve performance. You just saw the demonstration on using is in scope function, and probably the purpose is clear to you. That is the end of the demo on this particular topic. We will be moving to the next topic in a few seconds. We will now discuss Module 5 to check how to add measures to Power BI desktop models. When you create a visual and use a column to provide value for the visual, the automatic behavior of the column to summarize its data is known as implicit measure. If you are going to write a formula to create some values from a column value, that will be known as explicit measure or simply measures. In this module, we will focus on simple implicit measures and touch upon explicit measures. When I speak about implicit measures or using a column to provide value for a visual, there are three things I need to understand. Number one, the behavior of a numerical column. Number two, the behavior of a text column. Number three, the behavior of the date column. Let me show them in action and then continue the discussion. I am in the Power BI file in which we have worked in the previous module. Let me open a plain page, new page, where there are no visuals. As we have already discussed, the name of the table is called Asia, and we have quite a number of columns. Some of them are numerical columns, some of them are date columns, some of them are text columns. Let me create a card visual and then call for the value from a numerical column called profit, and then I get sum of profit, and the aggregation sum is happening by default. However, this can be changed to average, minimum, maximum, and so on. So this is how a numerical column will behave if you call for the column's value inside a visual. Let us now have a look on how a text column will behave. So in the same card visual, I am going to uncheck the profit value. Would like to include the values from the country column, which is a text column. When I click this, I am able to see an information called Bangladesh, first country, which means that if the names of all the countries are alphabetically sorted, the very first line item will be shown inside this card. However, the behavior of this text column that can be used inside a visual can be also a last value in the alphabetically sorted list. Now you can see the last value. It could also be the count of numbers or count of rows in that particular column. We have 25 not 1 rows, as we discussed in the previous example. We earlier had 2500 rows and then we add 1 row for testing purpose. So we have 25 not 1 rows. I believe all of you can remember this. I can also go there and ask for a specific value called distinct count, which now says the number of countries, distinct countries in this column is 28. This also we discussed in the previous example. So probably you will be able to remember. So the behavior of a text column when it is called within a visual is to provide either the first value or last value in the alphabetically sorted list and then gives me either the count or distinct count of the rows. So we just saw the behavior of a numerical column. We just saw the behavior of a text column. Let me now uncheck the text column from this card visual and then call for a date value from order date column. When I seek a date value within a visual, the implicit measure gives me earliest order date. This can be changed to the latest order date, like the first and the last values in the alphabetically sorted list. This will be the earliest and latest order dates, or rather date columns earlier and the latest values. Even for a date column, we can identify the count, how many number of rows are there in the date column, and how many of them are unique. We will be able to find out. This is a simple introduction about using an implicit measure. There are certain limitations in using implicit measures. To explain that, let me take up this case. I have created a table in which the year values were brought from the calendar table called CY. Profit values were brought from the Asia table, implicit measure. Units sold were brought from the Asia table, again an implicit measure. I'm now going to pull profit again to the same table. And this time, I am going to change the aggregation from sum to average. I am now getting a value called average of profit. And what do you think about this average of profit? Is it now talking about the sum of profit per year divided by units sold or something else? Before trying to understand what exactly this average of profit is trying to convey, let me go to my measures table and open the Asia profit measure, which was a simple explicit measure that we have created in the previous module. It just says that get me the sum of the values from Asia table's profit column. On similar lines, I am going to create one more simple explicit measure. And that measure is total units sold equal to get me the sum from the units sold column in the Asia table. I'm going to hit enter. Now, with the help of these two simple measures, I'm going to create a compound measure. And the compound measure that I'm trying to create is very simple. It says average profit equals the Asia's profit value, that is a measure, divided by another measure called total units sold. Hit enter, then that measure will also be created. When a measure references one or more measures, it is known as a compound measure. Let us try to pull the value into the same table called AVG profit. Now I'm getting a slightly different value. Just to get a quick confirmation, let me use the calculator from my Windows machine to divide the sum of profit for the year 2010 by the number of units sold, which is nothing but 1591489, and that gives me a value 72.53. The average of profit shown here may be a different value, but you may be interested to find out, Raja, tell me what exactly that is showing. To help you understand about what that value is speaking, I have created one more measure called a transaction count using another DAX function called count rows, which will count the number of rows in the Asia table. And if I'm going to filter that for the year 2010, I'll be able to understand that there were 324 transactions happened for the year 2010, and the sum of profit value is divided by this number of transactions, and that is what is shown here as the average of profit. I'm also using the calculator to confirm that what this value actually means, and now you will be able to understand with implicit measure. It is pretty much possible for an user to mistake what this average of profit is talking about. However, if I'm going to use explicit measures and if I want to show this as my average profit in terms of sum of units sold, I need to start writing explicit measures. So we are now trying to understand the difference between implicit measures and explicit measures. To provide a quick summary, implicit measures are simple to use. They are flexible in their summarization behavior. However, you cannot use an implicit measure when your data will be queried by MDX, multi-dimensional expressions, or in a paginated report. There is a danger that the user will set a wrong summarization behavior, owing to which the report created may differ from the report expected. So that is what we experienced in terms of identifying the average of the profit. Am I trying to show the average of profit in terms of the units sold or in terms of the number of transactions per year? So these are the places where it is always a good idea to create an explicit measure, then make use of that so that the user will get the correct view of the report. In addition to implicit and explicit measures, we do have something called a quick measure. With a quick measure, you will be able to select an option from a list of common calculations and add the results to the selected table. You may ask me a question, "Hi Raja, why don't you give me a quick demo on creating a quick measure?" Yes, I'm going to do that. For that purpose, I'm going to talk about the profit year over year percentage we have calculated in the previous discussion. So we wrote a formula with a variable declaration to identify the profit year over year percentage. I'm now going to create the same information through a quick measure. So let me click on quick measure, and from the list of calculations, I'm going to choose an option called time intelligence, in which year over year change is what I want to calculate. That needs two values. The first base value is about the data and the second one is about the date. I'm going to provide Asia profit as the data and then the date column from my CY table. Number of periods is going to be 1, which means that I want to have year over year. So it is going to be 1. I'm going to click add, and that will create a measure automatically in the name called Asia profit year over year. And you can see the formula. It is also using a variable declaration. In the previous example, when I was using a manual calculation, I used a function called same period last year. However, this quick measure is using a function called date add. I'm going to bring the value to the table. then I'll be able to see the results are exactly matching with what was calculated in the previous example. So this is a simple introduction about a quick measure. You might have noticed that this quick measure was erroneously created by me inside the Asia table, whereas I do have my own measures table. It is pretty much simple to move this measure from this table. You can click on the measure, you can go to the home table and then choose my measures. Then you can see it is moving to the my measures table. To provide a quick summary of our discussions, we started with identifying the difference between implicit and explicit measures in terms of a statement, then identified the behavior of numeric columns, text columns, and date columns. We have also identified the uses and limitations of an implicit measure. We identified methods to write simple measures using DAX, and then we created a compound measure, which is a combination of more than one measure. We have also identified about quick measure and how it can be used. Finally, let me touch upon the difference between calculated columns and measures. While both calculated columns and measures are defined by using a DAX formula, and both are calculations that you can add to your data model, they differ from each other in a few ways. When I talk about the purpose, calculated columns extend a table with a new column, while measures define how to summarize model data. In terms of evaluation, calculated columns are evaluated by using row context at data refresh time, while measures are evaluated by using filter context at query time. This is a major difference. In terms of storage, calculated columns in import storage mode tables store a value for each row in the table, but a measure never stores values in the model. In terms of using a visual, calculated columns, like any column, can be used to filter, group, or summarize as an implicit measure, whereas measures are designed to summarize the data. That is the end of a demo on this topic. We will be moving to the next topic in a few seconds. The learning points on 6th module are about adding calculated tables and columns to Power BI desktop models. However, we have already discussed about creating calculated tables in the previous part of this video. So let us focus on understanding row context. Let us also discuss the different ways in which a new column can be added to the model and which of them will be a best way for our requirement. When I speak about row context, the formula for a calculated column is evaluated for each table row. In addition, it is evaluated within row context, which means the current row. Assume that you have a date column and you want to create a weekday column as a calculated column. When the formula is evaluated for each row, the weekday column reference returns the column value for that row. However, row context doesn't extend beyond the table. There could be a few occasions where if your formula needs to reference columns in other tables, you have two options. You can use the DAX functions called related or related table if the two tables are related. You can use the lookup value function if the tables are not related. If your tables are related, it is always better to use related function instead of lookup value, as it will usually perform better owing to ways that relationship and column data is stored and indexed. Row context is used when calculated column formulas are evaluated. It is also used when a class of functions known as iterator functions are used. Iterator functions provide you with the flexibility to create sophisticated summarizations. They will be discussed in a future video. We should also understand three possible ways in which a column can be added to your model. If your data source is a relational database, and if you have the skills and the permission to create a view, it is a good idea to do so. From the view, you can acquire the data in Power Query. In case if that is not possible, then you can add custom columns using M to Power Query queries. This will be the recommended method whenever possible because they load to the model in a more compact and optimal way. However, you can consider this if you cannot handle the requirement in the source. The third final method is to add calculated columns using DAX to model tables. This could be the only possible way in certain scenarios. For example, you have a calculated table and then you want to add a column to that. Another scenario will be you want to create a column using a specialized modeling function such as related or related table, or using parent-child hierarchy, which are all specific to DAX only. With that introduction, let me show you some demonstration on the discussions we had so far. I have a Power BI file that has acquired data from a SQL server and the storage mode is import. The name of the source file is 2M sample and we have 2 million rows of data. I also have another dimension table, date table in the name called CY, and the date column from the CY table is connected to the order date column in the 2M sample table. Let me open the table view to show you the number of records. We do have 2 million rows of records. I have a date column called order date, using which I would like to create a calculated column for this table. And the name of the column that I am going to create is called weekday. I have just typed the formula with which I am going to create my new column, that is a calculated column. I'm going to hit enter, and then you can see the weekday is populated. The formula for a calculated column is evaluated for each table row. So that was a statement about row context. And you can see the values are available for every row. It is evaluated within the row context, which means the current row. That was a statement that you are now able to see. The next scenario is about a column in the CY table. So let me open my CY table, and I could see a column called QTR, that is quarter of the year, where I have used a nested if function. Since these two tables are related to each other, I want to acquire this column from the CY table to my 2M sample table. So I go to the 2M sample table, would like to click on new column, simply call it as QTR equals related, then simply choose the required column from your CY table, hit enter, then you will be able to see the QTR values are populated in this table. So in the discussions, we spoke about using related function, which is a specific DAX function. And these are the places you are required to use DAX to create a calculated column. Let me speak about a different scenario now. We have a column called total profit. Assume that this column is not available in the source. You need to create that. Will you be creating it in the source? Maybe possible if you have access to the source, if you have the skill sets, you can do that. Will you be doing it in Power Query? Pretty much possible. I can create a custom column over there. Will you be doing it in Power BI using DAX? That is also possible. So 3 ways we are going to discuss, and we need to identify which is the best method out of them for adding a column. I repeat, please assume that we don't have a total profit column. I am now ready with a formula with which I am going to add a column to the table. The formula says, get me the difference from the selling price and the unit cost, which will be the profit. That should be multiplied by the unit sold so that I will be able to see the profit per order. Hit enter, and the values will be populated for each row in the table, that is row context, and you will be able to see the profit value that has now been calculated is similar to the total profit that is already existing. I once again repeat, assume that we don't have the total profit column. We need to create a calculated column for that purpose. I am now going to create a similar column that is called a custom column in Power Query editor. For that purpose, let me get rid of this column for a moment. The column is now removed. In the Power Query editor, I need to add a column that should be a custom column. The name of the column is going to be profit, and the formula is going to be selling price minus cost of the product to be multiplied by number of units being sold. No syntax errors have been detected. Looks like the formula is going to work fine. Click OK, and it is going to create a profit column, which is known as a custom column, and the type of the data is alphanumeric ABC123. I need to change it to decimal number. Then I can load it to the model. I can click on close and apply in the home tab. Now the profit column that was created in Power Query is loaded to the model, and you get the same results. So this is the second method, and out of these two methods, which will be ideal? Beyond any doubt, doing this in Power Query editor is the right way, because the data will be loaded into the model in a more compact and optimal way. Let me remove the column once again from here. Go to the report view, save the file. I have now opened my SQL Server Management Studio and I am in a particular database called Global Edge, in which there is a place called views. We have described about creating a view in one of the previous videos. Probably some of you can remember that. Anyways, I am going to right click on these views to create a new view, and SQL Server is now asking me a question, Raja, from which table you wanted to create your view? And I am talking about the 2M sample table. I am going to click add to that. I can close this dialog box. I can expand this window so that I can see a more number of columns. I can choose whichever column I want. For example, I need the region column, I need the country column, then I need the item type, then order date, order ID, unit sold, unit price, unit cost. For obvious reasons, I'm going to ignore the total profit column because we are assuming that it is not available, and that is what we are trying to create using a formula. So I'm just going to ignore these three columns in the view. And let us see what is going to happen. Now the question is how you are going to create a new column in view in the SQL Server. Alright, in the select statement, I just typed my requirement, which you can see as highlighted. The same old formula. The difference between selling price and the cost of the product multiplied by unit sold. Then I'm using a SQL command that this value should be declared as profit. Then I'm going to save this as a view for which I'm going to give a name called add column. Then I can use this view to get data to my Power BI file. Alright, I'm going to close this. Now I'm going to get the data from a SQL Server using the view called add a column. When I check this box, you will be able to see the columns that are available in this view, and you can very well see profit column available here. When I click on load, the new table is loaded into the model and the name of the table is called add a column. Unfortunately, I have used the direct query storage mode, so I am not able to see the data here. That should not be an issue for us. Let me create a card visual and call the value from the old 2M sample table total profit column. I could see a value here, 784.59 billion. In another card visual, I am calling the data from the profit column, which is a calculated column, and the calculation is happening in the underlying source, that is the SQL Server, in the view component. So I'm pulling the value from a new table called add a column from the profit column, and I can see the same value appearing here. So there are three ways in which you can add a column. Number one, best method, if possible, had it been a SQL Server, and if you are permitted to do that activity, create a view or create a query in the source itself so that you add a column there. That column comes to your Power Query. The second best option is create a custom column in Power Query, and only when there are no other options possible, you can think about creating a calculated column in Power BI using DAX. That is the end of module 6. We will be shortly moving to the next module in a couple of seconds. Okay, in this module, we are going to discuss about DAX time intelligence functions that can be used in Power BI desktop models. Time intelligence relates to calculations over time. Most of the times, we need calculations over dates, months, quarters, or years. On a very few occasions, you may need calculations based on hours, minutes, or seconds. In data analysis expressions calculations, time intelligence means modifying the filter context for date filters. So this is the most important learning point. If you are new for DAX and new for time intelligence, we are going to modify the filter context for date filters. The basic requirement for creating time intelligent functions in a Power BI desktop model is to have at least one date table. A date table is a table that meets the following requirements. It must have a column of data type date or date and time, known as the date column. The date column must contain unique values. The date column must not contain blanks. The date column must not have any missing dates. The date column must span full years. A year isn't necessarily a calendar year. It could be a financial year also. The date table must be indicated as a date table. If you want to learn everything about creating date tables, please watch my video part 2, in which it has been discussed in detail. There are a few functions that can help to summarize over time. One group of DAX time intelligence functions that is related to this activity is given below. The first function I'm talking about is called dates YTD, which means year to date, which returns a single column table that contains dates for the year to date in the current filter context. You can pass this function as a filter into the calculate function. Calculate function is again a very powerful function about which I have mentioned a lot of information in my video D for DAX. The second function to summarize over time is called total YTD that evaluates an expression for year to date in the current filter context. We do have total QTD and total MTD functions. While the total YTD function is simple to use, you are limited to passing in one filter expression. If you need to apply multiple filter expressions, use the calculate function and then pass the dates YTD function in as one of the filter expressions. The third summarization function is dates between, which returns a table that contains a column of dates that begins with a given start date and continues until a given end date. Similar to that, we have another function called dates in period that returns a table that contains a column of dates that begins with a given start date and continues for the specified number of intervals. Another group of DAX time intelligent functions is concerned with shifting time periods. The first of them is called date add that returns a table that contains a column of dates shifted either forward or backward in time by the specified number of intervals from the dates in the current filter context. Parallel period is another function to shift time periods, and this function returns a table that contains a column of dates that represents a period that is parallel to the dates in the specified dates column in the current filter context, with the dates shifted a number of intervals either forward in time or back in time. Same period last year returns a table that contains a column of dates that are shifted 1 year back in time from the dates in the specified dates column in the current filter context. We do have many helper DAX functions. Some of them are next day, next month, next quarter, next year, previous day, previous month, previous quarter, previous year, and so on. If you want to know about time intelligence functions in depth, please watch part 4.1 of my video where many of these functions were discussed in detail. Let me now jump into a demonstration and then come back to discussions of points. I have a data model readily available in my system. The name of the fact table is sales, in which there is a column called bill value, a numeric column, based on which I'm going to create a couple of measures. One of the conditions is that the model should have at least one date table. I do have one date table here called CY that fulfills all the conditions for being qualified as a date table, and the date column from this date table is connected to the order date column in the fact table. With this introduction, let me go to the report view. I would like to show you the very first measure I have created, an explicit measure called BV that opens the bill value column from the fact sales table and then sum all the values, plain and simple. And the second one I'm going to speak is called BV MTD. As we had just discussed, this total MTD or total QTD or total YTD are functions that will provide summarization over time. So, if the filter context here is date, as you can see from the table, I have dates on 1st January 2019, 2nd January 2019 and so on. The total MTD function is expected to add the values of bill value one over the other because it is a summarization function. When you look at the formula, it says bring me the total MTD of BV column or BV measure as per the date that is available in the date table called CY. Plain and simple. The only thing is we cannot add additional filters even if you want to create an additional filter here. Let me reconstruct the total MTD function so that you can see what I'm talking about. I'm going to start with total MTD, on which expression, the expression is called bill value. That is a measure that I already created. From which dates it should happen from my date table, date column, and then it is accepting one filter. just one filter. However, in this example, I'm not going to provide any filter. That should be fine with me. I'm going to close the bracket and then hit enter, and that is how this formula was constructed by me. You can see a kind of color coding in the BVMTD column in the table, that is conditional formatting. The lower values are having kind of orange colors. The moment the values are increasing, they are getting green shades. And as you can see here, on 31st January 2019, the darkest shade is available, after which the color goes back to orange, which means this function called MTD keeps on summarizing the bill value till the end of the month, and then on the first day of the next month, it is reset so that you don't see a summarization here. Let me quickly give you another clue here. On 1st January, we have the same figures in both the columns. On 2nd January, you can see the value on BVMTD column as the summation of day 1 plus day 2. 3rd January, you can see the summation of day 1, day 2 and day 3 and so on. This goes until 31st January because it is a MTD function, month to date, and once the month is completed, it resets and then starts afresh. Let me now speak about dates MTD function, which should be passed inside a calculate function. It is giving the very same results. There is absolutely no change in the results. Both total MTD and dates MTD are giving me the same results. The only difference is going to be I'll be able to pass additional filters in dates MTD function. Let me reconstruct the formula here so that you can understand about additional filters that can be applied. I'm going to start with a calculate function. What needs to be calculated? The bill value with reference to dates MTD, and that should pick up the date from the date table's date column, and then you will be able to see that I will be able to apply filter 1, filter 2, filter 3, etc. if at all it is required. In this case, I am not going to apply any filters. I am going to close the formula here, and that is about the dates MTD function. Let me now speak about another summarization function called dates between. As you can see, this is going to calculate the measure called bill value using the DAX function called dates between from the date table's date column for dates 2nd January and 3rd January of 2019. When you look at the screen, you will be able to find out the total of these two values, and that is what is shown in the card. So summarization is happening for any number of days that you are going to define. You are going to define a starting date, you are going to define an ending date, and all the values in that range will be added, and that is the purpose of dates between function. We do have another function called date in period, which I have mentioned as d per, for which we are going to define a starting date, and then it will be continued for the specified number of intervals. So starting from 1st January, it should travel for 5 days. So 1st January, 2nd January, 3rd, 4th and 5th, you will be able to see the summation available in the MTD column, and that is what is being shown inside the card visual also. So this dates in period is another way of summarizing from a start date. Instead of mentioning the end date, you are mentioning how many days need to be used as an interval. So these are the 4 functions that are called as summarization over time. Let me now speak about another function called date add, which is a shifting of a time period. So we have the date add function. I have mentioned +5 within brackets just to give you a clue on what it is going to do. When you look at this table, the first line item is 1st January 2019. That is the current filter context. And the job of the date add function is to travel for number of days. That is, it is going to shift either forward or backward depending upon the number that you are going to define here. In this case, I am using number 5, which means it will be traveling starting from first, it will travel for 5 days and then reaches the 6th day and then identifies the value of BV on 6th day, and that is what is shown somewhere here. Now you will be able to understand what this function is trying to do. It is shifting the current date by 5 days, and if I am talking about 1st January, it is giving me the value for 6th January because the interval I have defined is 5 days. So this is a simple introduction about the date add function, which is comparison over time or which shifts the time periods. In this case, it is shifting the time period by 5 days We do have another function called a parallel period, which is doing the same job of shifting the time period, for which I have another sheet in which a simple table has been already created by me. You can see the name of the month and the bill value, and then I have created two different formulas. One is called a current quarter and the previous quarter. I'll show you the formula for current quarter, which is using parallel period function, in which I'm simply using 0 and then I'm using the periodicity called quarter. Whereas in the previous quarter, I'm using -1, which means go back by 1 quarter. When I say 0, you need not have to travel either forward or backward, remain as you are, which means the current quarter. When I say -1, go back by a parallel period of 1 quarter. When you look at the table here, the current quarter value should be giving me the summation of the first 3 months here. As you can see from these 3 numbers, for the first month, second month and third month, the summation is this. So the current quarter is getting calculated. And for April, May and June, these values are shown as a previous quarter because the previous quarter function moves back for a parallel period of 1 quarter. I repeat, it moves back by 1 quarter. So for the second quarter, I get the total for month 4, 5 and 6, as you can see here, and so on. So parallel period is definitely a useful function that you can think of using in different scenarios. Since I have created a slicer here for the year values, we can check how it works when I filter the table using any of the years. The next function that we need to know is called same period last year, which is another time shifting function, which simply goes back by 1 year. Pretty simple function. I'm going to calculate the bill value by the DAX function called same period last year with reference to my date table's date column. And in the table, you will be able to see, if I'm speaking about the current filter context is year 2020, SPLY gets me the value for 2019. So it is moving back or shifting back by 1 year as per the description. Not only that, if you are going to create a visual for monthly values, the same SPLY will be moving back by 1 year in terms of month values, which means if I am talking about June 2021, then it goes back to June 2020. So this is a versatile function that can be useful on different scenarios. You can concentrate more on learning SPLY to use in different conditions. This is a very simple introduction about time intelligence in DAX. Let me now speak about a slightly different scenario and how the time intelligence functions can be used on such a scenario. We have an imaginary organization, ABC Housing Finance, in which the financial year slicers are provided. So this company is in India and the financial year starts in the month of April and it ends in the month of March. We are getting a clue here. Use year filters to check new clients added during that financial year. When I use a financial year 2018 and 19, I could see a value called new customers equals 2. So we need to check that and how this is getting calculated. Before that, let me show you the simple table in which I have got only 3 customers. As you can see, we had the first customer in the year 2017. The second and third customers looking to be incorporated in the years 2018 and 19. However, when you look at the actual months, 1st of April 2018, 1st of January 2019, both of them falls in the financial year 2018 and 19 because in India, the financial year starts in the month of April and ends in the month of March. We do have another table called payments with a transaction date column and I'll be making use of this table in the calculations. You are now looking at the formula with which the new customers acquired during a financial year was calculated. The dates between function returns a table that contains a column of dates that begin with the given start date until a given end date. When the start date is blank, it will use the first date in the date column. The end date is determined by the max function that returns the last date in filter context. The first variable stores the number of customers within a specific period. The second variable stores the count of distinct customers before the time period in filter context. In our example, if I am talking about year 2018 and 19 being filtered, then the second variable will be referring to the period called FY 2017 and 18. To check that, if I click on the first year value, we had only one customer and that customer is a new customer. And then during the second year, we had 2 new customers and the total customers are now 3. So this is an example for you to get an idea on how you can make use of time intelligence in scenarios of this kind, which will be frequently required in industry. Let me now speak about yet another concept called snapshot calculations. As you can see, we have an Excel sheet in which the inventory values are stored over a period of time. This is called a snapshot. Occasionally, fact data is stored as snapshot in time. For example, the inventory stock levels or account balances will be stored as snapshots in time. A snapshot of values is loaded into the table on a periodic basis. When summarizing such snapshot values, you can summarize values across any dimension except date. Adding stock level counts across product categories produces a meaningful summary, but adding stock level counts across dates does not. When you are summarizing snapshot tables, measure formulas can rely on DAX time intelligence functions to enforce a single date filter. I have loaded the data from the Excel sheet to a Power BI file and I have created a visual configuration which is a brilliant example of how not to summarize a snapshot value. Adding periodical snapshot balances together doesn't produce a meaningful result that you can agree with me. So for the first item ABC001, the stock on April is different, May is different, June is different, and there is absolutely no purpose in showing a report of this kind. Makes sense, Raja? Then how you are going to help me to create a meaningful scenario? Let me move to the next sheet where I have summed the quantity in stock using the last date function, which is pretty simple as you can see in the screen. I'm going to calculate the sum of quantity in stock column values from the stock table using the last date function. Last date is a semi-additive function in DAX about which I made some comments in one of the previous videos. I'm going to apply a slicer for Q1 and then you will be able to see the table is talking about April, May and June and the total value is perfectly talking about the last month balance or last date balance. When talking about Q2, I do get a meaningful result in terms of the values for September that has been shown as the values of total. In terms of Q3, I do get values exactly as expected. When I move to Q4, unfortunately, I don't get a total here. That is because we don't have data for the months called Feb 2023 and March 2023, owing to which the function called last date has identified that the measures are returning blank values and the total column is blank. Let me now speak about a scenario where I am getting the correct results even when there is no value for February and March. As you can see in your screen, Q1 I get the correct results, Q2 I get the correct results, Q3 correct results and Q4 also I am getting the total value even though the months February and March are not available as on date. How this is working? I'm going to introduce the last non-blank function, that is an iterator function. It returns the last date that produces a non-blank result. It achieves this result by iterating through all dates in filter context in descending chronological order. For each date, it evaluates the past in expression. When it encounters a non-blank result, the function returns the date. That date is then used to filter the calculate function. The last non-blank function evaluates its expression in row context. The calculate function must be used to transition the row context to filter context to correctly evaluate the expression. If you are a first-time user of DAX, this may be slightly difficult. With a little practice, you will be able to write formulas of this kind where you can achieve the results as expected by you. So these are all some of the time intelligence functions that can be added to your model using DAX. A very quick summarization before we move to the next module. Please be aware that in data analysis expression calculations, time intelligence means modifying the filter context for date filters. You should have a date table with a certain rules, and there are functions which are used for the purpose of summarizing the data over a period of time, such as dates YTD, total YTD, dates between, dates in period. A few other functions are useful with reference to shifting the time periods, such as date add, parallel period, same period last year, and so on. When you want to calculate new occurrences of new customers, you will be using the dates between function along with the distinct count function, as we have just now discussed. And then we talked about snapshot calculations when you need to store the fact data as a snapshot in time. This is very important because creating a summarization over snapshot calculations cannot be done without the right formula. And we just saw that using last date function can be useful. However, there was a small error in that when we don't have a data for a particular period in the financial year or in the calendar year, and that was resolved using the last non-blank function. So that is the end of the delivery on this particular module called Module 7, Time Intelligence Functions in DAX. And we will be moving to the next topic in few seconds. I have kept open a Power BI file in my screen. For obvious reasons, I am in a blank page. I am now trying to open page 1 in the report. And you can see that the visuals that are available there takes a bit of time to load. Let me now click on the Optimize tab to open Performance Analyzer and then click on Start Recording, hit Refresh Visuals. Now you can see there are 3 card visuals and they are all taking different times. Let us examine which card visual is taking the longest time. When I hit on this particular card visual, this is the second one. When I hit the next longest time, 2156 milliseconds, that is the first card. And I could see the third card visual has taken much lesser time compared to the other 2 visuals, and that is this particular card. Let us now compare the time taken for DAX query between card 2 and card 3. For card 2, it is 2767 milliseconds. For card 3, it is 1426 milliseconds. We will find out which card is using what DAX formula or function. The first card using a plain and simple distinct count function to identify the number of countries from the country column in the 2M sample table. The second card is using a DAX function in which a filter is being applied to identify the number of countries where the units sold is greater than or equal to 5,000. And you might have noticed that this second card has taken maximum amount of time to refresh. The third card is using another DAX function called keep filters. I repeat, the second card is using a filter function. The third card is using keep filters function. Now you will be able to understand that even though both of them are returning the same results, the performance difference is significant. So, when we speak about performance optimization, it is important that you write the DAX formula in the correct sequence so that you save time on refresh. The sample file that I am using has acquired data from a SQL server, and the storage mode is direct query, which means that there is no data in the local copy. And whenever you hit a query, or whenever you try to refresh the visuals, the command is sent to the underlying SQL server, and from there the results are to be captured. With that introduction, let me now go to the second page of the report, wherein I have got 2 different slicers. If I am going to hit a particular region called Europe in the region slicer and then hit a particular item called clothes in the item type filter, then you can see immediately the total profit is changing according to the slicers that were applied. Please note that similar to I am making some options here for these 2 slicers, there may be couple of users trying to view this report from different parts, and they are all trying to send a query to the underlying SQL server. Whenever they hit a particular slicer item in a slicer, that will be immediately sent to the SQL server, and in turn more number of users hitting more slicer items will be creating larger amount of queries that is being sent to the source data. So these are the situation where you need to think about using an option called apply all slicer button. When I click on this, I'll be able to see an apply all slicer button available. And once it is available, I am now making a change in one of the item types. The figure is not changing. This is not yet applied. I click on another region, no change in the total profit visual, because I need to now click on the apply all slicers, then only the information will be passed to the underlying source data and then the results are captured. So this is one of the ways in which you can optimize performance, particularly when you are using more than one slicer in a report page. Let me get the performance analyzer once again to show you another important information. Let me click on start recording, refresh visuals. Please make a note of the time taken for the slicers to refresh themselves. Now I'm going to change the item type slicer from being a vertical list to a drop down menu. Now you can see this slicer has taken hardly 40 milliseconds. Let me clear this. Let me hit refresh visuals. Now you can see that the second slicer item type has taken 47 milliseconds to refresh, whereas the one with the vertical list has taken 1692 milliseconds to refresh. So if you are going to use a lot of slicers in your report pages, now you can make a learned decision whether you need to show them as a vertical list or a drop down menu. As informed already, this particular file is using a storage mode called direct query. When you are using a direct query model, you can go to the file, options and settings, open options, and in the current file section, you can click on query reduction, where you have a couple of options. Add a single apply button to the filter pan to apply changes at once. Add apply buttons to all basic filters to apply changes when you are ready. Instantly apply basic filter changes. Instead of adding an apply button to each slicer, we recommend adding an apply all slicers button to each page. That is what we already did. However, I am showing all this for your information that you may need to change some of them once in a while depending upon your situation. Let me now open the third page, which is a blank page. If you can remember, when I was opening the file, I was in a blank page purposefully. You may ask me, Raja, why you are doing this? When you open a blank page in your report, save the file and open it again, and then you open any page, you can see the visuals are taking some time to load. That is because there is no visual cache. When I am trying to do a performance analyzing activity using my performance analyzer, it is important that I must get rid of two different cache. One is the visual cache, for which I can use a blank page. The other one is called a data cache that can be removed by using DAX Studio, and my DAX Studio is now connected to the 2M sample file, where I can see an option called clear cache. When I hit this button, now you can see the cache is cleared. In addition to that, in the DAX Studio, I am able to see the hidden date hierarchy. That is a calculated table with different columns that is going to definitely affect my performance. So that is one of the reasons why I don't want to have the inbuilt hierarchy to be available in my files. To get rid of this inbuilt hierarchy, you need to go to File Options. You can do it for the entire Power BI files using the global option, or you can do it for the current file by hitting Data Load, where the Time Intelligence option called Auto Date and Time is available. You can uncheck the checkbox, click OK. When you open the DAX Studio again, you don't see the hidden calculated table of date hierarchy, and this is one of the ways to improve performance of your models. I have kept open another report in my screen in which I am in a particular report page. For the year 2009, I am going to hit this segment called Home Office. I could see an indication in the tooltip saying that right click to drill through. When I right click, I am able to see an option called drill through, which can take me to two different pages if I want. I just wanted to go to a page called segment report. That is going to open me a new page with different reports that I wanted to view with reference to the Home Office segment for the year 2009. So which categories are there, what is the total sales, what is the segment's total sales, top 5 states, total sales by priority, and then a table with some information that I wanted to see, and so on. I can go back, I can choose year 2011, the same segment called Home Office, right click, go to the same segment report page, then I can see the home office segment this time for the year 2011 only. So the idea is when you create a drill through page like this, you will be able to provide additional information. Instead of trying to show everything in a single report page, you can split them and show them in different pages so that the time taken for visuals to refresh will be reduced. You can now see yet another report in your screen in which I'm talking about the loans to deposit ratio report. Here I have the country map for India with bubbles. So when I hover my cursor to a particular bubble which says that the state selected is called Maharashtra, and there are 427 clients in this state for which I get a city-wise report. Which city has got how many customers? Maybe I can click on this bubble, then I can see all the information in the screen. Instead, if I can create a customized tooltip, then I will be able to see them as a separate image as and when I need. This is also one of the ways in which I can improve performance because I am not loading so many information in a single report page. I am trying to keep a part of the information that needs to be seen by the user as a tooltip. You may now ask me a question. Look, Mr. Raja, there are 2,727 total clients, out of which 427 are in Maharashtra. Pretty much good. But if I am going to choose a segment here in the slicer, let us say I am choosing commercial segment, I now have 401 clients. So what will happen to the custom tooltip page that you have created? I'll hover to Maharashtra state. Now I can see in the commercial segment, I have only 65 clients because the total number of clients itself is 401, out of which 65 of them from Maharashtra state, and I have a breakup per city. So creating a custom tooltip is one of the ways to optimize the performance of your models, and this is a simple example about the same. You just saw a demonstration on Module 8, Optimize a Model for Performance in Power BI. Performance optimization ensures that the consumers of your report get a good user experience. Your report may be running as expected during the test and development stages, but when published for a broader consumption in the production stage, users may report the following. Report pages are taking longer time to load. Visuals are taking more time to update. Most of the times, the reasons for the above negative experiences will be bad data model, bad DAX, or a combination of both. A smaller sized data model uses less resources and achieves faster data refresh, calculations, and rendering of visuals in reports. In general, the performance optimization process involves minimizing the size of the data model and making the most efficient use of the data in the model, which includes ensuring that the correct data types are used, deleting unnecessary columns and rows, avoiding repeated values, replacing numeric columns with measures, reducing cardinalities, analyzing model metadata, summarizing data where possible. When you intend to optimize the performance of your model, you need to check elements such as tables, relationships, DAX calculations, multiple visuals, redundant data. You need to check your measures and queries to ensure that they are used in the most efficient ways. When you identify the slowest query, probably you might have found the biggest bottleneck in your model's performance. We have already demonstrated on using the performance analyzer by removing the visual and data cache. So there is no need for me to read this particular slide. And this is also a continuation of the discussions about using the performance optimization via DAX query that we have discussed in detail in the demonstration. When we speak about visuals, if you identify visuals as the bottleneck leading to poor performance, you should find a way to improve performance with minimal impact to user experience. Consider the number of visuals on the report page. Fewer visuals means better performance. Any visual which is not adding value to the user may be removed. Instead of using multiple visuals on the page, consider other ways to provide additional details such as drill through pages and report page tooltips. And you just saw the demonstration on drill through pages as well as customized tooltips. Examine the number of fields in each visual. The upper limit for visuals is 100 fields, measures or columns. So a visual with more than 100 fields will be slow to load. You might find that you can reduce the number of fields that you currently use. This is just a question for you. If you are presented with a report page like this, what changes you will be making in this so that you can optimize this report page? Same question. For this page, what are the places where you can make some changes so that the report page will be optimized? The other elements to be considered for optimizing the performance of your model are relationships, columns, metadata, and column profiling tools. The auto date time feature is one of the important information that you need to remember in mind, about which we saw a demonstration, and we have identified how to get rid of that in case you don't need that. It is preferable that in a larger data model, you switch off the time intelligence, create your own date table, and make use of that hierarchy. Using variables in DAX formulas will certainly improve the performance that we had seen in many previous discussions also. Cardinality levels in columns is another area where you can improve performance. When you use the column distribution feature in Power Query, for every column you can identify distinct values count, the total number of different values found in a given column, unique values count, the total number of values that only appear once in a given column. When the unique count is low, it means low cardinality. When the unique count is high, it means high cardinality. Columns with low cardinality can be greatly compressed, and so such columns are good. Columns with a high cardinality, more unique values, cannot be compressed much, and hence they should be considered as a challenge for file size and for reports performance also. From the images given below, we can understand that the order priority column contains just 4 distinct values that gets repeated and no unique values. This is a good candidate for compression. The order ID column contains 1000 unique and 1000 distinct, which means no duplicates. This is definitely expected as this column should have unique values only. This is not a good candidate for compression, but we can do nothing in this case, because order ID should be different from one another. I don't want to have a duplicate order ID. However, look at the index column. Do we really need it? Can that be removed? Such columns can be removed to improve performance. Similarly, when you have a date and time column, splitting them into date column and time column will help to reduce cardinality. Cardinality levels in relationship is another area. You can think about creating a summary table in the source when possible instead of a detailed table. This will greatly reduce the model size. You can also group the data so that the model size can be further reduced. When your data is from a source such as SQL Server database, you can use the storage mode called direct query to reduce the model size that we had already discussed. Optimizing direct query models, we're using the option called apply all slicers as well as query reduction. We have discussed a few minutes ago. Create and manage aggregations is another way in which performance can be improved greatly. And if you want to see a detailed information about manage aggregations, please watch part 5.3 video from 43rd minute to 49th minute. That is the end of this module called optimizing performance of your data models. And we will be moving to the next module in a few seconds. I have a simple sales data in the form of Excel tables. My fact table is known as fact sales and a couple of other dimension tables are available. I do have one user table in which the names of the users, their email ID and the state for which they are in charge are also available. I want this data to be taken to Power BI, in which I want to create one single report that will be showing the names of all the states along with the sales for category. However, when a particular user logs into the system, he or she must be permitted to see the data as per the permission that was granted to them. For example, if the username is GR, he must be able to see the data only for Andhra Pradesh. This is known as a row level security that can be implemented in Power BI. There is another type of security called object level security, in which the entire column or entire table can be hidden from being viewed by specific users. There is a difference between object level security and row level security. I repeat, in row level security, we don't hide the entire column. We hide only specific rows and allow only specific rows to be seen by an user. In object level security, it is possible to hide the entire column for certain users. With that introduction, let me try to create a static role by hitting the modeling tab and then clicking on manage role. When I initially opened this dialog box, nothing is seen here. But the moment I click create, I could see the names of all the tables in my model and I can create a role here. If I am talking about Andhra Pradesh, that is what the user should be permitted to see. I can type here the name of the role as AP, short form for Andhra Pradesh, which should be filtered in dimension states table by creating a filter for the state column that should hold a value called Andhra Pradesh. I can click save and then I can click on view as. Then you will be able to see the role that I have created is available here. I can choose that from the checkbox, click OK. Now you can see that the values are showing only for AP because that is the rule that I have created. You may now ask me a question. Mr. Raja, you have created a role called AP or Andhra Pradesh, that's okay. How you are going to map this role with a specific user in your organization? Before that, let me hit the stop viewing so that all the state names are now visible in the matrix. Coming back to the question, I have created a role in the Power BI desktop, but mapping that with the user should happen in Power BI services. For that, let me save the file and then click Home tab to publish this file to one of my workspaces called YouTube samples. It may take a minute for the file to get published, and once it is published, we can open that in the Power BI services. It is published now. I can click here to open the file here. Then I'll be able to see the entire report. Now let me speak about something else. You can now see here, current user is Raja at mso365global.com. When you look at my Power BI services, this is the user who has logged into the Power BI services. The same current user function in the desktop has captured the device name and username. I have not explained about this earlier. I am sorry about that. Let me speak about this particular DAX function called user principal name. User principal name is one of the DAX functions that can be used to capture the name of the user. In the desktop, it will be capturing the name of the user along with the device name. In Power BI services, it gives the login username. Alright, Raja, everything is fine. Now tell me how you are going to map the role you have created called AP to one gentleman called GR in your organization. So I need to click on my workspace, go to the data set of the published file and click on a place called security, where I can see the role that I have created in the desktop is now available in Power BI services. However, there is a numeric value called 0 inside that, which means that this role is not yet mapped to anyone. Now I am going to map this to one user in my organization, gr at mso365global.com. Click OK, click add, click save. So I have created a row level security role in the Power BI desktop, published the file to my Power BI services, then map the role to one particular user. Now the number has changed from 0 to 1, which means that this role has been assigned to one user, and I can click here to test as role. When I do that, I'll be able to see only Andhra Pradesh value. However, you may now ask me a question, but Raja, we are still able to see your login here, correct? That is because I am still in my browser in which I have already logged in. Can you give me a demo in which in real life how this is going to happen? If that is your question, I can do that right now. I just need to open the report part of this file, click on share, and then I can share this to that particular user called gr at mso365global.com. This will be sending an email message to that user saying that Raja has shared a report with you. Please open that. Now I have opened a different browser in which the other user has logged in. You can see gr at mso365global.com has logged in over there, and he is checking his email, and he could see that Raja has shared a Power BI report with him. There is an option called open this report. He is going to click that, and that will shortly open the report for the other user called GR in his Power BI services space. Now you can see his username is captured. He is also having a pro license, and he could now see the data only for Andhra Pradesh. Let me go back to the browser in which I have logged in. You can now see This is the browser in which Raja has logged in, and this is the browser in which another user has logged in. For him, the data that is visible pertains to one particular state called Andhra Pradesh as per the row level security role that was designed. This is how a static role can be designed, very simple to design, but it will be very difficult to maintain. For example, what will happen if I am going to add one more state to be viewed by GR? How I am going to implement this? Will I be creating one more role in the name called Arunachal Pradesh? Then I will be mapping it to GR. If that is the case, for Gujarat, I need to allot it to Nageshwar, who should also be permitted to see the data for a couple of more states. So if I am going to create static roles, then I will be creating one by one, mapping them one by one, and that is not going to be a good idea. So that is a place where we need to think about creating dynamic roles. To give you a clarity, I have added one more state for GR. Let me save this Excel file, go to my Power BI file and hit refresh. Open the dimension users table to confirm that the second state is also now visible in the model. Looks to be good. I can go to the report view, click modeling, click manage roles, and then remove the old static role called AP. I'm going to delete that. I'm going to create a new role in the name called UPN, stands for user principal name, for which the dimension users table should be filtered on the email ID column. I have just typed the DAX function called user principal name, open and close parenthesis, click save, click view as. I'm going to check this box called UPN because that is the name of the role, and the other user is going to be gr@mso365global.com. And I can see two states popping up over there. I can also see the current user as gr@mso365global.com. Let me now check this with another user's name. I am testing with a user called Nageshwar. Click OK, and I could see exactly the states for which he has been granted permission. So this is a simple introduction about using a dynamic role to create row level security. You just saw a simple demonstration on the 9th module, enforcing Power BI model security. I already spoke about RLS and object level security, and the information that I need to insist is if your model follows star schema, Power BI can enforce rules that filter dimension tables, allowing model relationships to efficiently propagate those filters to fact tables. Rule expressions are evaluated within row context. Row context means the expression is evaluated for each row using the column values of that row. When the expression returns true, the user can see the row. You can define rules that are either static or dynamic. You just saw the creation of a static rule, and you also saw the creation of a dynamic rule. Dynamic rules use specific DAX functions that return environmental values as opposed to constants. Environmental values are returned from three specific DAX functions. Username or user principal name returns the Power BI authenticated user as a text value, and it is a good idea to use user principal name instead of username. Custom data returns the custom data property passed in the connection string. Non-Power BI reporting tools that connect to the dataset by using a connection string can set this property, like Microsoft Excel. You just saw how we created a dynamic rule and how it was implemented also. Setting up the role mapping in Power BI services was also demonstrated to you. I have not spoken about security group, let me touch upon that. Instead of assigning or instead of mapping users one by one, you can have all the users in security groups, and then you can map a role to a group. That is going to be helpful. Let us say that you have a distribution list called group 1 in which there are 5 members including Mr. X. You are assigning a role of Eastern region to group 1 so that everyone in this group can view the data only for Eastern region. You have another distribution list called group 2, members of which can see data related to Western region. If Mr. X is now transferred to Western region, he should be permitted to see the data pertaining to Western region only and not for eastern region. What you are supposed to do? You simply need to remove Mr. X from group 1 and add him as a member of group 2. It is much simpler compared to any other methods. So please make a note of this. If you start talking about dynamic roles, with many members of your organization should be given permissions to see the data, and there is a possibility that there will be some changes in the roles. Probably you should think of creating a security group in which it can be implemented. If you're talking about direct query sources, SSO or single sign-on can be implemented. When your data model has direct query tables and the data sources supports SSO, the data source can enforce data permissions. This way, the database enforces RLS and Power BI data sets and reports honor the data source security. In the previous example, we have used UPN to identify the user and then restrict the access as per UPN. The role was set up in Power BI desktop and implemented in Power BI services. On the other hand, with data source supporting SSO, you can create a report, publish it to the services. There is no need to create any role in Power BI desktop. You need to enable SSO when you set up the data source credentials in Power BI services. When report consumers open Power BI reports, Power BI passes their identity to the data source. The data source then enforces RLS based on the identity of the report consumer. As I informed already, object level security can completely stop a column from being viewed. There are a few considerations and restrictions on OLS. You can have a look into the error message. The above error message will appear for a user who doesn't have permission to access a table or column. This message is little confusing or misleading for the user and can create a negative user experience. If the user is not aware of OLS, he may think that the report is broken. The actual reason is the salary column is restricted for this user. You need to consider whether to set up OLS or think about creating a separate set of models or reports for such users. A few limitations on OLS are: you cannot mix RLS and OLS in the same role. If you need to apply RLS and OLS in the same model, create separate roles dedicated to each type. Also, you cannot set table level security if it breaks a relationship chain. For example, if there are relationship between tables A and B and C, you cannot secure table B. If table B is secured, a query on table A cannot transist the relationships between table A and B and C. In this case, you could set up a separate relationship between tables A and C. Measures cannot be secured. However, a measure that references secured objects is automatically restricted. While creating RLS or OLS, ensure that your model enforces data permissions correctly and efficiently. A few guidelines that you need to keep in mind are: attempt to have fewer data sets with well-designed roles. By using dynamic rules, create fewer roles. A data-driven solution is easier to maintain because you don't need to add new roles. To achieve faster query performance, try to create rules that filter dimension tables instead of fact tables when possible. Validate that the model design, including its relationships and relationship properties, are correctly set up. Use the user principal name function instead of username function. It provides consistency when validating the roles in Power BI desktop and Power BI services. Rigorously validate RLS and OLS by testing all roles. Ensure that the Power BI desktop data source connection uses the same credentials that will be applied when set up in the Power BI services. Our discussions on Module 4 to Module 9 are now completed. Hope the delivery was clear and you are able to get the points without doubts. If you have any questions on the topics discussed, please share them in the comments and we shall respond. Thank you for watching this video. See you in the next video. If you have not subscribed to this channel, please don't forget to subscribe, like, comment and share. Thank you.